Welcome all to another SNL episode with Timur. Timur here is our guest from Trustblock, and we are live with Will Academy. Thank you, Timur, so much for doing this. Today, we will be going over this course that Timur has created over auditing on the newer blockchain, as well as tackling different security issues on the newer blockchain. So, would love for you to introduce yourself, Timur.
Yeah, awesome. Yeah, happy to be here. Thank you for having me, Sanket. And yeah, looking forward to continue this conversation. And yeah, quickly about me. Before actually working at Web3, I used to be like a Web2 security engineer at Invicti Security. Those guys created like NetSparker, Acunetics, like a web vulnerability scanners that NASA use, Apple uses, etc. So big guys use them. That was basically designing security checks there. And when actually like everything in Web3 happened and it was like getting super popular, I was like, yeah, I mean, it sounds good idea to actually explore that field because like no one's doing security there, especially like back in the days, like in several years ago. So I was like, yeah, let me hop in there. And yeah, I joined Halborn. Was working as a security engineer at the beginning. Then I started leading a practice and a team um, for like substrate and near security teams. I'm mainly like a Rust focused. I also did like several Solidity audits, but like my love is Rust and I like substrate and near. That's why I decided to just focus my efforts there. And afterwards, like let's say 6 7 months ago, I chatted with currently my co-founder and I decided to join Trustblock as a co-founder and CTO. And yeah, that's how it started. And here I am.
Perfect, perfect. So, how was your time at Halbon? Did you enjoy some interesting projects or anecdotes from Halbon that probably
Uh,
related to you?
I mean, look, I mean, it was super interesting experience because when you especially shift from Web 2 to Web 3, it's like you're getting bombarded with knowledge in the first weeks because you have no idea what the Web 3 is, and you're like, what the hell is happening? And you have to just keep like learning. Basically, like before you get your foundation on Web 3, you basically uh you spend a lot of time learning and afterwards it's getting better and like the I would say like the basically the one quick anecdote I can give you is that basically on near side I managed to actually find one critical vulnerability in a really first near project with it, and it was super awesome. Actually, that gave me like a boost of confidence that I'm good at this. I mean, it's I should probably focus there, and it was I also added this project in my course as an example. But yeah, I mean, like the overall experience was amazing there, and I still love doing auditing even though I'm currently more on the dev side on the things. And yeah, I'm still auditor and security guy at heart. And if yeah, I mean, always like exploring projects on my free time. So yeah.
Got it. So, before we actually get into what Trust Block is and into the details, you did mention about being bombarded with knowledge in the first few weeks of jumping to Web3. So, obviously, you were a developer in Web2 before this, right? But for somebody who's directly jumping into Web3 as a developer, what would you suggest as a roadmap to start learning development and then potentially auditing? So, how would you suggest that a new developer directly jumping into Web3 without much knowledge of Web2 also can make a journey here? What would you
Mm.
suggest?
I mean, look, it's like it's hard to give suggestion of the like, cause look, it's gonna be different for everybody. But like, if you just starting out, I would suggest to just basically understand what the basic concept what the blockchain is, how it's done, like at least on the basic level behind this is what the hell is proof of work, what the hell is proof of stake, what the hell what is that's layer one actually is what is layer two. So it's like to give you like at least an idea of what's happening there, and then jump to basically I would suggest if you coming from if you're already coming from like a, let's say, strongly typed languages, C++, or maybe if you're a Rust developer already, it's like easy, just go do some development on near. It's like it will be super easy for you, like if because you already like the language is Rust there, you just basically learn a new library, so to say. But if you're like, let's say, coming from like a background of like Python, JavaScript, web, I would not suggest you to actually go to Rust. I would suggest you to learn Solidity because it's easier, and you will actually like Solidity community is huge. You'll learn a ton. Um, Sit on Twitter, subscribe to top guys in the industry, because like the main news I get and main resources and tips I get is on Twitter right now. So because everything is scattered all around, there is no like one resource. So yeah, if there is like one, the best resource I have for learning something is Twitter right now in Web3, to be honest. And if there is a list, I guess there is a list somewhere, the top people to subscribe for Solidity development. Go ahead, do this. So yeah, so it depends on the person.
Got it, got it. Okay, so finally starting into the interview, jumping right into it. We would love to first get an introduction to what Trustblock is, how did it come about, a few words about your co-founder maybe, and what do you guys focus on? What's your core
Um,
area of expertise?
yeah, for sure, for sure. So, basically, how it's all started, I actually joined the project later on as a co-founder. It was started by my right now co-founder. He basically started a Trustblock, and then he decided to that he needs someone to help him out. So we actually chatted on Twitter. We actually met on Twitter like randomly and chatted a bit. We decided, yeah, it sounds like a good match, and let's go for it. And that's how we met. We actually met on Twitter. And the so yeah, that's another thing. I mean, sometimes you might actually get super nice opportunities on Twitter if you sit there, but obviously don't spend 12 hours a day. Just yeah, just a quick note. Yeah, and basically what a Trustblock is. Trustblock lets basically build an infrastructure for auditing companies and auditors to publish their audits on chain. By that, you will get by doing this, or every audit is linked to a smart contract. So then we also calculate statistics metrics for each auditor in our system, like a business metrics like a TVS, total value secured, total value secured, and we have a huge like a database and platform of auditors and their statistics, so projects can easily actually find auditors based on real data and not just a word of mouth. So projects can just go, let's say, to Quill Audits. Actually, super happy to have you on boarded, and see that your Quill Audits audit a lot of projects and they secured a lot of things. So yeah, let me just go ahead with them. And maybe, for instance, I'm a project and I want to only pick, like my project is on like, I don't know, Avalanche. And I only want to pick auditors who actually work majority in Avalanche, and I can sort this out also. And that data that auditors generate is actually can be used by other platforms like insurance protocols, let's say, to decide whether to insure certain project, for decide for a certain amount depending on the data generated from your reports. Reports are actually active objects and not just PDF reports. All the data is communicated between the whole ecosystem. So insurance protocol can decide to insure certain project for the certain amount uh, depending on the number of issues discovered, and like different like we also provide like UI labels for platforms. Let's say platforms, like example, like a coin market cap can use their UI labels to display on their website next to a project saying that was audited by that person, how many issues were found, how many things were secured, etc., and so on and so forth. So now reports are active objects that can be used across ecosystem, and yeah, and hopefully making finding new auditors a lot easier. So yeah.
Now, that sounds absolutely amazing because the need of the hour is to get more auditors into the ecosystem and for them to be highlighted through the social media so that people can, projects with small budgets can also hire auditors for private audits. But a lot of auditors don't have the foresight to reach out to these projects. So probably such projects can, use your platform to get connected with
Yeah,
the
for
auditor.
sure, for sure. I mean, and you can find auditor like tailored to your needs. Not every single project, especially for small one, doesn't need to hire tier one auditor who's going to be super expensive.
Yeah.
But you can check out like tier three auditors, see that actually they're doing pretty well. They audited that many projects based on everything is based on real data in our side. They audited that many projects, they saved that many things, and their majority of their audits, let's say on BNB, that you as a project is targeting. So you don't have to spend, like, say, $300,000. You can go to a smaller one, which is also gonna do a job if you're like a small project and you don't have a lot of funding. So
Makes sense. Makes sense. So, I mean, obviously, we talked about how you got into Rust, and you already knew Rust, and so you directly started exploring Newer as a library, sort of. So, and you being an auditor, do tell us about some of the security features that are provided by Rust as a language, which actually, and you can pitch them against Solidity as well, to make it more interesting.
look, I mean, the main thing is like Rust is like a general purpose language. Is not like Solidity, who is like DSL, like specifically built for Ethereum. It's like general purpose language, can build anything with it. And the main, I would say, the security feature of Rust is like their whole system of ownership and borrowing. So in simple terms, like each value can have just only one owner, aka variable. So that's an easy concept. And when you borrow something, you basically take a reference of a variable. You can have unlimited amount of immutable references or only one mutable reference. And that system allows you to actually prevent issues such as let's say null pointers. You cannot have null pointer in regular case in Rust. There is option type actually, which literally says option type is just encapsulation of you're either going to get the value or you're going to get none. So you have to explicitly handle it. Like it's not going way around it. You cannot have null pointers. You cannot have double free, use after free issues that you can have in C++. Basically, use after free. You allocate an object on a heap, let's say, then you free that memory on the heap, and then you try using this object. That means use after free. And when it happens, there's undefined behavior. Everything can happen. The program might crash. You might access some random memory somewhere. This does not happen in Rust if you're using just a regular safe Rust. So it already, like by default, prevents many things that C++, for instance, has. So at least, and everything is in compile time. So like you can, and compiler is super strict also, and everything you have to, all the error handling you have to do explicitly. You cannot just say like, okay, I'm not going to handle it. No, you cannot do this. So by encapsulating everything, it basically, if your code compiles, by default, you won't have any memory, let's say, the majority of memory issues. You won't have buffer overflows. So it's already like amazing thing. You won't have random runtime errors in majority of the cases. I'm not saying about like a logical errors. It's like it's different. It has it, but like memory issues, you won't have them if you use safe Rust. But there is also another thing. You can use unsafe Rust. There is like unsafe Rust. You literally write unsafe brackets. You write unsafe Rust inside. It still has all the capabilities of the safe Rust, but it's more, let's say, flexible. It lets you do some stuff that are not usually permitted. Like in Rust, you cannot have use an initialized variable. For instance, you can have let x just basically initializing x and then printing it out. You cannot have this in Rust because it's uninitialized, and the data there is like you have no idea what's there in that part of memory. So, but if you use unsafe Rust, you can explicitly have an initialized variable and then print it out. So, and it's like, it's actually dangerous. You shouldn't be using like initialized variables. Actually, if you want, you can, actually, I was preparing the update for my near course Rust section. I can just show you a couple of examples if you,
Yeah,
if you like.
that would be awesome. That would be awesome.
Yeah, can you just let me share my screen?
Okay.
Uh, okay, so.
I think you can share now. Yeah.
Yeah, now I can share. Okay, just give me a second. Yeah. Okay, just give me a second. I need to enable it on basically privacy settings. Just give me a second.
Sure.
Um, sorry, I need to actually reopen Zoom to actually let the sharing. Can we actually pause the recording and then just continue?
No, okay. So what we can do is you can leave for a second and then join back at the same time.
Sorry?
You can okay, I'll pause the recording and then you can restart.
Yeah, because at the end we have to show the POC also. So
Yeah.
technically, yeah. Sorry about that. I mean, that's a
No,
new
no issues.
laptop and it has like, I haven't opened Zoom in ages. So sorry about
No
that.
issues.
Okay, so I mean, here was basically like a quick example of, let's say, initialized memory. Like we have just on Rust. Like imagine we don't have unsafe and you just want to print it out. You won't be able to do this because of the compiler rules and like safety rules that the Rust has. It literally just tells you like, while it's not initialized, you cannot do this. But if you have like an unsafe block where you basically, this thing means explicitly set value as uninitialized. And then if we save it, now we will be able to actually print it out and we will get some like a random bytes at the time when this value was like in the memory. So if we just run cargo run binary of an initialized memory, we can see that we just printed some random bytes at the memory of here. So if I repeat, you're gonna get different result and different result. So it's dangerous because I mean, depending on different contexts, your application might just crash if you get some bytes which are not like in your context are parsable or you are not expecting them. So yeah, that's the one thing that Rust prevents. Like use after free, for instance. That's another example. So here we just basically allocate 1, 2, 3 U128 on a heap. Then here we just printing the referencing the pointer to a value and then printing it out. It works. I mean, we just basically referencing a pointer. But then we're converting the value to a raw pointer. Raw pointer means it's just super raw pointer, which does not have any like security measures. It can point to incorrect memory, it can point wherever. So that's why when you interact with raw pointers, you by default have to use unsafe. You cannot interact in a safe Rust with a raw pointer. So we're converting it to a raw pointer, and we in unsafe here, now we can print the value. In both cases, the value is going to be the same. It's going to be 1, 2, 3. Now let's say we're dropping the value. Basically, we're delocating the memory where the value exists. We're dropping it, and now we're trying to access it again, even though it's already dropped. So, and technically, it's not allowed, and it's super dangerous because I mean, because you have no idea, like because you already freed the memory here, and you're pointing to invalid memory right now. So if I just do cargo run, then use after free, you can see that we just got like some random bytes in a memory. And depending obviously on the context, if there is like some memory issues, I mean, you probably saw like many exploits due to memory issues.
Yeah.
You basically overriding a memory, you're trying to access some memory which points to, let's say, different parts of the code to execute some different paths. So those kind of vulnerabilities are usually coming from like a memory issues, like use after free, double free, and so on and so forth. Like double free, easy, like you have value, basically we just allocate value in a heap, creating row pointer, just an example. Then we drop and we basically deallocate the memory, and then we're deallocating the memory again. Technically, it shouldn't happen because it's called double free. That's why basically you're deallocating the memory again, and it's not allowed because you cannot deallocate it like memory which already deallocated. So basically, your program will crash. So if you will be able to reach that path in some real world scenario, you might just crash a program. So yeah. And it's easily happen in like many, like in C++, for instance, because there is no like by default security measures like here in Rust, for instance. You can see the program just crashed. So yeah, that's just a quick example why Rust is useful. So at least you're gonna sleep good at night knowing that you don't have to deal with this stuff. If you write safe Rust, you just write it and you know that you won't have any memory issues. So yeah, okay, let me just stop sharing my screen. And
There's some great insight into memory safety issues as well. And I mean, we do see a lot of exploits due to memory issues. So I think I mean covered a decent part of why Rust is so secure and the way that it provides you with, I mean, allowing you to choose whether you want it in the unsafe form and you want failure speed or I mean, I do feel that's a significant advantage over C++, as you did mention.
yeah.
So, I mean, you worked with quite a few, I mean, I'm assuming you worked with quite a few audits based on Rust and Unit, right?
Sorry, I couldn't hear you. Can you repeat, please? It's
I'm saying, I mean, I'm assuming that you must have worked with quite a few audits with Rust and building on the newer blockchain.
whether I worked with audits on Rust, not on blockchain, you mean?
No, no, I'm saying, have you worked with projects on the newer blockchain built with Rust?
Yeah, because look, I mean, near blockchain, it has basically a couple of SDKs. So you can work on assembly script. They even recently have JavaScript SDK, never used it. The main like projects, like production ready, super like top projects, you can see they're written in Rust SDK. So, and I decided to go with this. Like the near core is written in Rust. Their Rust SDK is super nice. Majority of things in near are written in Rust. So that's why I'm using it.
So, I mean, so what must be the most common security risks or attack vectors that you see on the newer blockchain associated with Rust and Near, and how do you feel that developers can mitigate them? Some of the most common ones.
Yeah, I mean, on the basically all the Rust security issues exist on near safe Rust security issues because everything is written there as safe. So meaning that you can have like a casting overflows, integer overflows. It's actually not only on near. It's like if any in software is written on Rust, it's going to have it. It's like on Substrate, on Solana, you're going to have Rust issues. Okay. So, and how to prevent them? Like Rust issues can be prevented if you just, for instance, as a starter, you enable overflow checks during runtime, because when Rust code is compiled in debug, basically Rust has two modes: debug mode and release mode. When code is compiled in debug mode, runtime overflow checks are enabled. So if there is like overflow happened, you won't get like wrapping around the type. You will actually get panic. Basically, you're going to get an error back, which is better than having a random value. Basically, if you have U8, if you reach like a more than 255, it's going to go back to 0, right? So you won't have it if you compile in debug mode, because overflow checks during runtime are enabled. You're going to just get an error, so which is good in this case. But when you compile in the release mode, the runtime overflow checks are disabled. So when you compile in release mode, usually you compile in release mode to get more optimized build, faster, more optimized, smaller, and that's how you upload your stuff, like let's say to near blockchain or just the regular stuff. But overflow checks are disabled by default in runtime. So if you get an overflow, your value is going to wrap around and you're going to have a lot of logical errors. So you basically specify in a, let's say, cargo.toml file. Cargo.toml file is just like, let's say, config file. If you're using a Solidity Foundry toml, like, basically there you define configuration. So cargo.toml, it's specifically for Rust. And you basically add to your profile release overflow checks enabled true. So basically you enable them also for release mode, and it's for starters, it's going to actually already prevent a lot of integer overflows in your during runtime. That's for Rust. There are many other things, but if we move to near security in near, basically it's a smart contract language. It has a lot of like a concept similar to regular Solidity. So I mean, basic issues, access control, we all have them. You forgot to put on the owner modifier, you already wrecked. So it's like it's access control. Keep in mind that. Also, another thing is that in Rust we have basically in Solidity there's delegate call. In Rust we have basically two callers, two way of calling. There is basically predecessor account ID and signer account ID. Predecessor account ID is the actual caller of the function, the one message sender, if you want to just direct caller of the function. And signer account ID is to actually who signed the transaction. And you can have a signer account ID who signed transaction A, which calls transaction B, which calls transaction C. And if you're using in your code signer account ID, the value you're going to get is actually the original signer. So basically there are two ways. And if you have signer account ID in your access control, it can lead to people trying to to perform some phishing attacks on you. If you're, let's say, they know your owner and they know that you're using signer account ID in your privilege function, they might actually create like a fake page or something for you to sign a transaction to malicious contract, which will call then your privileged function in your original contract. That's also a thing to pay attention to in here. So you have to, in majority, in 90% of cases, you should be using predecessor account or direct caller of the contract. And there are also like many ways to, for instance, Rust has some sort of, many people call it reentrancy, but I don't think it's the correct wording for it. It's more of like a race condition. Basically, when you interact with external contracts, you operate over promises. Let's say you call a contract, then you wait until promise is resolved, and then you call a callback, basically like execute a function, external function, then you have the code .then, and then you execute your callback. And during that period between you calling, let's say you call the function A, external function from your code, there are like a 2-block delay between function being executed, basically between promise being resolved and the callback. So during that 2-block delay, you technically can call any function inside of the contract. Not by any function, I mean any allowed functions to you. And depending on the context, you can cause like many logical errors. So if you, let's say you have a staking contract, and then you, let's say, I want to give you like a super easy example. Let's say we have just a random, a random staking contract where person just calls it to stake some money, and it's external. So you just basically create, you go to specific function to call, like a function called stake. You stake some money. That function calls external contract, and then it stakes money there. And then a callback actually deducts money from you. Okay. And imagine that deduction, if deduction is like happening on callback, and if the issue, like let's say if the issue happened and you're not reverting a change, because if the issue happened on a staking contract, you have to like nothing is reverted, only there is reverted. You have to manually revert changes on your main contract. So imagine you can call this function twice, you stake twice. Basically, you call it twice, like super quickly. So before the first callback received, you call it super quickly. Basically the first callback, the first call will let's say put 100 near to your account in different contract. Second call put another 100 near, so already have 200 near. But your actual money is only 100 near, but you managed to stake 200 there, because first callback when received, it deducted and made your account 0, and the second callback actually basically just I think caused a bug, or basically caused the panic. But since you're not reverting any changes on that separate contract, you still have 200. You have 200 tokens, even though you only had 100 in the beginning, just because you called it super quickly. So it's like, that's why I'm like thinking it's thinking of it as a more of a race condition than just basically re-entrancy. Yeah, basically in the course, I'm also explaining this, and it has like a diagram, so it's like a lot easier to track what's happening. So yeah, that's basically the super specific near thing, that race condition, I would say, which haven't seen much in other languages. No, sorry, in other protocols. Yeah.
So, I mean, we've been talking about, I mean, Timur and Rust. So, there's one thing that always comes to mind, that are there certain security guidelines or security features that Near as a blockchain also provides to its users building on top of it?
Yeah, I mean, look, Near actually, that's a good thing. Like, I really like Near's security overall. That's how they approach it, because they have, for instance, like for their own contracts, they have like, let's say, bug bounty. I know they're actually having super rigorous security checks on their side, because many people rely on their, let's say, core contracts and like their whole system. So they have super rigorous bug bounty. They have super nice like a security like security audits overall. In addition to this, for their projects, they also opened up in recent, not recently, but like several, like 6 or 7 months ago, can't remember. Basically, they'll refer you to their auditing partners. So you, as a project, can fill a form, and you're basically gonna get like a top-notch like auditing companies that they already check that they have capacity to accept you. So they already like trying to make that every single project in the Near ecosystem is audited. It's not just some random project. So that's why like I haven't heard like so many hacks in Near ecosystem. Maybe it's because it's not, obviously it's not as popular as Ethereum one. That's one thing. But another thing is that I really believe that it's because like Near does the great job of actually making sure that their projects are secure and audited, and provide all the necessary support for you to get audit. Let it be like, if you let's say affiliated, if you're already building on Near, you might actually require a grant for your auditing also, which actually gonna make your system safer. So yeah, I mean, and also like another thing, there is like the Near is trying to be super user friendly. So they're actually, even though it's Rust, their contracts are super easy to read. So it's not like their whole concept is super easy to code and execute. That's why there are not that many bugs that I can point out, at least from my audits, compared to like a Solidity, for instance. So yeah, that's also another thing.
Got it. So, I mean, I think we covered most of the things we talk about specifically regarding Rust and Neo. So, I feel now would be the right time to get into an overview of your security course on Neo. And I think this is the part that most people are waiting for to get an insight into the course and what's happening, what are the updates. Would love to know.
Yeah, sure. Yeah, awesome. I mean, look, I prepared the security course, and I tried to make it in a way that it's super based on my experience, meaning it's let's say practical bugs that I found. So even sometimes I'm attaching report if it's there, if it's public, so you can actually check it out. So that's the good part. It's not like obviously there's certain bugs that I know exist, but I didn't find them in the wild. For them, I prepared some quick and let's say quick and dirty examples, but some bugs that I actually found, I'm actually using the real code there that I saw. So you guys can see it like how it's used in the wild, how you can actually spot it. And I try to use as many diagrams, as many like visual clues as possible, so it's not because I know it's like concepts sometimes might be hard to grasp, and visual cues are the easiest one to follow. And my course also has the Rust section, so that's a good thing. Also, I believe because let's say you just if you're just pure Rust dev and you have no idea about security, at least you'll get some basic understanding of general Rust security before jumping to near security. And if you're just beginner in Rust, or maybe you don't know how to code well, but you know how to read it, you after actually finishing the Rust section, you'll be able to spot some bugs just by reading the code. So because Rust security, like Rust language issues exist everywhere. Doesn't matter if it's near Solana, Substrate, Cosm, Wasm, doesn't matter. If it's written in Rust, there are going to be issues. So that's why I have a Rust security section there also. And like I'm trying to make it updated as possible. I already like started adding additional content to Rust security section. Haven't uploaded yet, but already adding them. And also in addition to this, I have several also topic on Rust near security that I haven't covered, but I want to. So yeah, I'm trying to keep it as updated as possible. And yeah, hopefully people will appreciate this and have like I will have more auditors not only on Solidity side but also on the Rust near Substrate side. Even if you don't pick near, but at least you learn some Rust security, might give you boost of confidence to try different things. Because Web3 is not only Ethereum, and we should have auditors, well-rounded auditors who know many things. So yeah.
Yeah, that's so true. And this line that you said at the end, Web3 is not only Ethereum. I mean, it's something that the people in the ecosystem should also pay attention to because a lot of interesting projects on a lot of different. I think we had the Sui blockchain on which we do move, right? Just come up, and then we have your Substrate. I mean, a lot of these interesting blockchains that offer a lot more to the existing ecosystem.
Yeah,
And
sure.
congratulations on this course. And I mean, I'm truly a fan, and I've heard only good things about this course. So thank you so much for helping out the ecosystem without seeking personal benefit or gain through it, like we've seen a lot of players in this ecosystem do.
Thank you very much. Thank you very much. Appreciate it.
So I think we are down to the last bit, and I feel that we have a demonstration for POC in your coming up. So
Yeah.
I would love for that to take place.
Yeah, sure. Yeah, let me just share my screen. Please let me know because I'm using like a that's the wrong one, I guess. Wait, it's not the wrong one. Or is it? Because I'm using a white screen, so it might actually look super small. Um, yeah.
Okay, I
Can
can see.
you?
Yeah, yeah, I can see.
Yes.
Okay,
Let's do like this. It's
that's
better.
better. Yeah.
Okay, so basically, I don't know if you heard like a project called Sweat Economy. Basically, basically you you earn tokens by doing some physical activities, and
Okay.
it's like, first TLDR, there is no actually real bug in the project. I just copied the project and changed the function. Don't try to, there is no bug in the real project. So yeah, people, if you're watching this, don't try it. There is no bug in the real world. So okay, so basically what we have here. So the main thing, when I was actually browsing the real code, I saw that they have a function called record batch. When you hear something batch, it means they're executing a lot of things, and probably there are for loops inside. So if you hear something batch, check for instance, in Rust, or sorry, in Near, there are bugs related to gas exceeding. Rust has limited amount of gas you can attach to transaction. If you exceed that amount, your function won't work. So if you, for instance, if you're iterating over large array from your storage, and your storage grew so much, you won't be able to actually execute your function. Your function will get DOSed because you cannot attach more gas than you permitted. So you basically, it's called prepaid gas exceeding. And also, like, the another thing is, we basically, in Near there are events, but in Near there are basically some rules from which you have to follow when you emit an event. So event cannot, in one single transaction, cannot have more than 100 events. If you have more, it's gonna panic and gonna receive an error. Everything's gonna get reverted. And another thing, event message cannot exceed 16 kilobytes. If you exceed this, also, there's going to be an issue. So in original sweat economy code, they actually been using a separate, like a vector here. Forgot the name, steps batch. Yeah, steps. Basically, they would been using steps batch, basically this. So it means that they're actually passing it manually. So there is no issue. They can control how much accounts to actually utilize in a vector. And they basically, what they do, it's like not going into calculations. They have super complex calculations here. So it's just like they iterate over that array, do some calculations, do some deposits, and then at the end push event messages to this structure. And then at the end, they emit an event. So depending on amount of accounts you have in the vector, so not tuple between account and U16, you're going to have the longer event message and more iterations inside of the loop. So that was their original code. And it's not vulnerable because they're actually passing it manually so they can control it. But I changed it. So here now we have a storage. Basically, we have the steps batch in the storage. And imagine they reach to a point they have so many users, or there is a function called, let's say, register user, which basically, like, let's this one that's I added register account, which basically just register message sender and predecessor account ID with 10,000. So you might imagine the attack scenario here. Since the vector is taken from a storage, I can technically call this function with different accounts a lot of times to fill up the storage so much so that you won't be able ever to execute a record batch, because either you don't have enough gas to execute it because you have like a iteration over the vector in the loop, or you're gonna have issues with event here. I will make your event message so big that it's going to exceed 16 kilobytes and you won't be able to execute the transaction. So to make things simple, and so that we don't have to wait until I create, because it uses message sender here in this example, to create a lot of accounts and register them, etc. I have integration tests here, which basically just prepares our integration test. Here's the actual test. Prepares integration test, deploys our smart contract. Smart contracts are deployed via WASM files, by the way. And here we basically just generate an oracle, because the record batch is called by oracle. And then I'm just generating some random accounts here. And during basically initialization, here initialization is called new, as you can see, like here, here init function, basically initialization as constructor, its validity. So, and we have to add those guys, steps batch. I'm just adding it directly in the beginning so that we don't have to wait 10 minutes until I actually generate those accounts. So I'm adding them in the beginning. Let's say someone decided to exploit it and like register accounts, a lot of accounts, and they have a lot of them. So here we go. And then I'm adding them. And then here, if we want to have some extra accounts, I'm just basically calling register account with the new randomized generate account. This part is taking super long, usually because it actually does stuff on chain, like generating account, creating a private key for it. So that's why I'm going to mainly rely on the initial vector that we provide, super large vector here, and maybe add a couple of guys here so that you can see the concept. So let's say we have, I don't know how much, let's say we have 250 accounts. Let's say we want 250 accounts in the vector during initialization. And let's say add 5 during, actually, let's do like this, 400. And add 5 during actual on-chain calls to register account using register account function. And then afterwards, we just basically add Oracle, and then we call record batch. And here we shouldn't be able to call record batch because we have such big array that our event message is going to be more than 16 kilobytes. So let me just run it. Cargo run, cargo test. Let's say, let's go integration tests. Go output. Okay, sorry, that's the wrong one. Give me a sec. Can you see my another terminal? I guess no, right?
No, I can't.
Okay. Okay, just give me a second then. I'm executing the wrong thing. Okay. Yeah, it should work. Yeah, okay. Okay, so first, we're basically going to generate a lot of accounts. Yeah, here we go. It's already failed. So here we exceeded the prepaid gas because our array is so big that we cannot attach more gas than max gas. Max gas, we're already attaching like a max allowed gas, and we cannot attach more, but we have such big array. So that's why now this function technically DOSed. We cannot call it ever again. And now let me actually decrease it so that we don't exceed prepaid gas, but actually I will show you the issue with the event message. So now let me restart it. Okay, it should. Yeah, it's taking a bit longer because it's generating some accounts. So just a second. Okay. Okay, so here we go. So basically, first we generated some accounts, and at the end, we basically trying to call record batch. But in this scenario, now we get another message, another error message. The length of error message, sorry, log message is this value, which exceeds the limit of this, which is roughly, I guess, 16 kilobytes. So that's why we now cannot actually call this function. So in real world scenario, I saw this in let's say in a real token project. So basically what they had like regular tokens. You can sometimes like register an account just to add it to storage so that you can, let's say, add allowances to it, etc. So, but that register account was like just there, and it was like it was public. It didn't have any security issues per se, but you could register a shitload of accounts. So you could register a lot of accounts, and because of this, one of their methods which executed on the batch could be DOSed because of this. So yeah, I mean, takeaway here, when you see a function basically which iterates over an array, or if you see a function called like something batch, like even here, like a min batch, probably it's gonna also introduce issues if they weren't passing manually the array here. So if there's something batch, double check it for any denial of service issues related to gas or events or event message lengths in near. I'm pretty sure it also applies in Solidity in some sense, at least on the gas side. So yeah, I mean that's pretty much it on my side here on the POC.
Yeah, this is great. Thank you so much for doing that. I'm sure everyone learned a lot from this. And I'm sure that after that, a lot more people are going to subscribe to your course. I subscribe to your channel, seeing how comprehensive that was. I mean, I'm sure that was great.
Would love to. Happy to teach. Happy to have more people join the Rust gang. So yeah.
So I think we are at the end and we've run out of time also. Thank you so much for agreeing to do this. It was a real pleasure to have you. And we love Trustblock, and we love the functionality there. We love your work. Thank you so much for agreeing to do this.
Thanks for having me. Thank you. Thank you very much.